Have you ever pondered the mysteries of the universe, like what happens when you fall into a black hole? Well, buckle up, cosmic explorers, because today we're diving headfirst into the enigma that is black holes. These cosmic behemoths have been causing quite a stir in the scientific community, and for good reason. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their gravitational pull. Now I know what you're thinking. Are black holes just cosmic vacuum cleaners, sucking up everything in sight? Well, not quite. In fact, if our sun were to suddenly turn into a black hole, we wouldn't be sucked in. We'd just freeze to death. Quite the chilly thought, isn't it? So it's clear that black holes aren't just out-of-this-world hoovers after all. But don't worry. We'll keep peeling back the layers of this cosmic onion in the scenes to come. Stay tuned. So, you might be wondering who first stumbled upon these baffling cosmic phenomena. Well, allow me to take you back in time, to the early 20th century, a time when a certain genius with wild hair and a penchant for violin was reshaping our understanding of the universe. Yes, I'm talking about Albert Einstein, the father of the theory of general relativity. Now, Einstein's theory, as mind-bending as it was, suggested that space and time were interwoven into a four-dimensional fabric called space-time. And this space-time could be warped and twisted by mass and energy. In other words, the more massive an object, the more it bends the fabric of space-time around it. This idea was quite revolutionary, and it led to some truly strange predictions. One of them was the possibility of an object so dense, so incredibly massive, that it could bend space-time to such an extreme that nothing, not even light, could escape its gravitational pull. This was the theoretical birth of black holes, but despite this theory, Einstein himself wasn't entirely sold on the idea of black holes. In fact, he once famously said, "Black holes are where God divided by zero." A little mathematical humor there for you. The real credit for the discovery of black holes goes to a few keen-eyed scientists who took Einstein's equations and ran with them. Folks like Carl Schwarzschild, who found the first solution to Einstein's equations that described a black hole, and John Michell, who, even before Einstein, suggested the existence of dark stars, a concept remarkably similar to black holes. These brilliant minds, armed with nothing but chalk, blackboards, and an insatiable curiosity, ventured into territories unknown and came back with a concept so strange, so mesmerizing, that it continues to baffle us to this day. So black holes weren't just plucked from the pages of a sci-fi novel, they were a mathematical prediction. The first real black hole wasn't discovered until the late 20th century. Now, you might be wondering, why did it take so long? Well, spotting a black hole is a bit like trying to find a needle in a cosmic haystack. Our star of the show, Cygnus X1, didn't make its grand entrance until 1971. This elusive celestial celebrity was discovered not by its dazzling light, but by its darkness. You see, black holes are like the ultimate party poopers of the universe, sucking up all the light and leaving nothing but an inky void. But how do we spot these cosmic party crashers enter the wonderful world of X-ray astronomy? It's a bit like having superhuman vision, allowing us to see things that are otherwise invisible to our naked eyes. X-rays are emitted when matter is heated to millions of degrees, and let's face it, being gobbled up by a black hole is pretty hot stuff. So, when a pair of X-ray detectors aboard a satellite picked up unusually high readings from a point in the Cygnus constellation, astronomers were intrigued. They'd found a cosmic hotspot, but what was causing it? Well, it was a bit like a celestial game of Clue. The culprit, a blue supergiant star, about 30 times the size of our sun, dancing a dangerous tango with an unseen partner. This partner was pulling matter from the supergiant at a ferocious rate, heating it up and causing it to emit those telltale X-rays. So who was this mysterious dance partner? After much deliberation and a few cups of cosmic coffee, astronomers concluded it could only be one thing: a black hole. The first real one ever discovered. Talk about a stellar debut. But, of course, Cygnus X1 wasn't content to just sit back and bask in its newfound fame. Oh no, it had to go and challenge our understanding of physics too. But that's a tale for another time. And that's how Cygnus X1 made its stellar debut. Studying black holes isn't as simple as observing a star through a telescope. You see, black holes are the universe's ultimate hide-and-seek champions. They're so good, in fact, that they don't even reflect light. This makes them practically invisible to our eyes and conventional telescopes. So, how do you study something that you can't see? Well, that's the cosmic challenge scientists face every day. It's a bit like trying to find a black cat in a dark room, but instead of a cat, it's a cosmic object with a gravitational pull so strong, nothing can escape it. And instead of a room, it's the infinite expanse of the universe. No big deal, right? Scientists have had to get really creative to study these elusive cosmic entities. They use indirect methods of observation, which is kind of like trying to find out what's in a wrap present without opening it. They can't see the black hole itself, but they can observe the effects it has on its surroundings. For example, they look at how nearby stars behave or how gas and dust swirl around it. It's kind of like seeing the water ripple around a duck. You might not see the duck, but you know it's there. There's also the use of advanced technology, like radio and X-ray telescopes, which can detect the high-energy particles and radiation that black holes emit. And let's not forget about gravitational wave detectors, which can pick up the ripples in space-time caused by black holes merging. It's all very high-tech and sophisticated, kind of like a cosmic detective story. And if you thought your job was tough, just imagine being a scientist trying to study something millions of light years away that doesn't want to be seen. It's like playing the world's hardest game of Where's Waldo, but with less striped shirts and more astrophysics. It's clear that when it comes to studying black holes, scientists really have to think outside the box, or should we say, the event horizon. Why are we so fascinated by these invisible, voracious cosmic entities, you may ask? Well, let's delve into the depths of this fascination, much like a star being sucked into a black hole. Don't worry, it's less dramatic than it sounds. First off, black holes are the ultimate rock stars of the cosmos. They're mysterious, elusive, and have a certain pull that you just can't resist. They're like the lead singers of the universe, only instead of groupies, they attract cosmic dust and gas. And instead of trashing hotel rooms, they distort space-time. Talk about a wild lifestyle. But their star power isn't just for show. Black holes play a major role in our understanding of the universe. They're the perfect testing grounds for the laws of physics, pushing them to their limits. They challenge our understanding of space and time, matter and energy. They're like the universe's version of a pop quiz, except this one has the potential to rewrite textbooks. Moreover, they're not just abstract cosmic phenomena. They have a direct impact on the universe around them. The supermassive black holes at the centers of galaxies, for example, can influence the birth and death of stars. They're like cosmic midwives and undertakers rolled into one. Lastly, let's not forget about their starring role in popular culture. From science fiction novels to blockbuster movies, black holes have captivated our imagination like few other celestial bodies. They symbolize the unknown, the unexplored, the infinitely intriguing. They're like the universe's version of a cliffhanger, always leaving us wanting to know more. So from the scientific to the symbolic, black holes are fascinating for a multitude of reasons. They're the ultimate cosmic enigma, always at the center of intrigue and discovery. They invite us to question, explore, and marvel at the wonders of the universe. It's no wonder we're so drawn to black holes. They're the ultimate cosmic mystery. So what have we learned about black holes today? Well, we've journeyed across cosmic proportions, pulling back the curtain on the universe's enigmatic dark corners. We've delved into the tale of Cygnus X1, our first discovered black hole, and the astronomical challenges it presented. We've explored the importance of these cosmic phenomena, not just as celestial objects, but as keys to understanding the universe itself. We've seen that black holes are like the universe's magic trick, pulling matter, light, and even time into their unfathomable depths. They're the ultimate cosmic mystery, a riddle, wrapped in a mystery inside an enigma, only without the wrapping. And just when you think you got a handle on them, they throw a curveball like spaghettification. Yes, you heard me right, spaghettification. So as we continue our cosmic journey, peering into the unknown, we can count on our dark, mysterious friends to keep us intrigued, entertained, and slightly nervous. As we continue to unravel the mysteries of the universe, one thing's for sure, black holes will keep us on our toes.